I'll go through the solutions to the extra problems on equilibrium of forces that I've given you to prepare for test 2. So the first question is an object is being acted upon by 3 forces and is in equilibrium. Okay, so here's our object. One force is 60 newtons along the x-axis. So there's 60 newtons. I'll call that F1. The second is 75 newtons along the y-axis. Call that one F2. 75. What is the magnitude of the third force? Okay, so there's a third force. Obviously, the third force has to be down here somewhere in order for those 3 to add to 0. And this is what we're trying to find. Okay, so we do our table. Remember our x and our y. And they have to add to 0. So we'll list our forces F1, F2, and F3. You have to be careful of the positives and negatives. So F1 is in the x direction. There's nothing in the y direction. F2 has nothing in the x, but has 75 in the y. And F3 we don't know, but let's just call it F3x and F3y. Okay, so we know moving down the x column that 60 plus F3x must be 0. So F3x must be negative 60 newtons. So this is the x direction, and you have to do these separately. And then the y direction, we have that 75 plus F3y must be 0. And so F3y must be negative 75. That's how I know it's down there in the third quadrant. So to get the magnitude of F3, remember the magnitude, that's the length of the vector. We take the x component and square it. So this is just a right angled triangle. We use Pythagoras to get the hypotenuse. So negative 60 squared plus negative 75 squared. And we should get the answer. Just double check. 96 newtons. And so that is E. Okay, now if we wanted to know the angle, this question doesn't ask the angle, but if we did want to know the angle, this one, then we would use that the tan of that angle is F3y over F3x. Okay, so that's how you do that one. Let's do the next one. Number 2. An object, once again, has been acted upon by 3 forces and is in equilibrium. But now these forces are a little bit different. So we're just doing the same thing over and over again, but it's good practice. Just keep doing it. So one force is along the x-axis. So once again, F1 is 60 newtons on the x-axis. And the 75 now, it says it makes counterclockwise angle of 150 degrees with the x-axis. That's over here. That's counterclockwise with the x-axis, and that would be 150 degrees. Now your calculator would understand that if you wanted to put that in, but I don't really recommend you do that because you might goof it up. So you're much better to draw it and use this interior angle here, because then you can look and you can see there's the x component for F2 and there's the y component for F2. And this angle, it's 180 all the way around, so this must be 30. 150 plus 30 is 180. Okay, so let's do it again. Calculate, make our table, do the components. Hopefully if you do this 10 times, you'll be really good at it. Okay, so here we go. Now we're trying to find F3. Now I don't really know where F3 is. Might be in the third quadrant, might be in the fourth quadrant. It's got to be down here somewhere, but I'm not quite sure where, so I won't draw it yet. So let's do F1, F2, F3, the one we don't know. But we do know they have to add to 0 because it's in equilibrium. Okay, F1 is 60 in the X, 0 in the Y. Now F2 is negative because it points left in the X. So it'd be 75 cos 30. But it points up in the Y. So it's 75 sine 30. Okay, so we have to work these two out. And then once again, we're going to have F3X, F3Y that we don't know. Let's work these numbers out. 75 cos 30 is 65, negative 65. 75 sine 30 is 37.5. Okay, we know they have to add to 0. We go down the column. In the X direction, 60 minus 65 plus F3X must be 0. So that means that F3X is equal to 65 minus 60. So it's 5. So it's over there in this is going to be in the fourth quadrant, this F3. So the Y direction, we've got 0, 37.5 plus F3Y. So 37.5 plus F3Y has to be 0. So F3Y is negative 37.5. Okay, so once again, it wants the magnitude and direction this time. Okay, so let's sketch this F3 so we know where we're at here. It has a positive X, but not a very big positive X, only 5, and quite a big Y, negative Y. It points down. I know it's points down, so I'm just going to write 37.5. So F3 is here in the fourth quadrant. Here's F3. And we want its magnitude and its direction. Okay, so magnitude of F3, square root of 5 squared plus negative 37.5 squared gives us 38 newtons. And the angle would be the arctan of y over x, 37.5 over 5. Oops, something on my screen here. Okay, and that angle would be, make sure your calculators are in degrees. That's quite a steep degree. It's 82.4 degrees. Now I'd have to say below negative x axis. Now the answer says 260. 260, 260. Oh, that's funny. 37.5. 82. So what that means is this is 82 this way, then this is 360 minus 82. So 278. Something went wrong here. It says the answer is 260. Measured clockwise from the, they made a mistake. There's no way that that one can be 260 degrees. Okay, so I would recommend you double check this. So go through and make sure I did this right. F1 is along the x-axis, the second counterclockwise at 150. Yeah, so that's okay. Yeah, that looks all right. I don't know what went wrong with their answer, but that looks okay. Okay, let's carry on. 3. Piano mover. Okay, this is a pulley system. And it's a 1,000 Newton piano that this mover is holding. So here's the rope. This person is pulling down. Okay, so if we just take sort of a dot on the rope here. So person pulls down with force F. Okay, so call that one F. That means the tension in the rope pulls up on the person, and there's pulleys here, so pulley and a pulley. So whatever force this person pulls down on this rope with, that is the force everywhere, the tension everywhere in that rope. And remember, ropes only pull. So the rope would be pulling up on the person here with a force F. It would be running along between these two pulleys. Now this is attached to the piano. It's pulling up with the same force there, and it's also pulling up here with the same force. It's everywhere the same force, and it's attached there. Okay, so let's just look at this piano. Here's the piano. It's got two ropes pulling up. And if you were the piano and you were just this pulley, you wouldn't know where those ropes were going or what was happening. You would simply feel the tension in these two ropes pulling up, and you would feel the force of gravity pulling down if that piano were you. And we know this force of gravity, it says it's 1,000 newtons. It's already given in newtons. You don't have to go mg. Okay, and this is in equilibrium. So up equals down. Or if you wanted to do the y direction, the two forces in the y direction equal the force of gravity. So 2 times F must equal 1,000 newtons. And so F is 500 newtons. So the advantage of the pulley is you only have to pull with half the weight of the piano in order to suspend it. If you had 3 or 4 or 5 ropes, well, you would just divide 1,000 by 3, 4, or 5, and that's how hard you would have to pull. Okay, number 4, it draws the picture for you. It's this ornament, a 6 kilogram ornament, and it's got 2 ropes up like this. So this is similar to one of the one where you had the guy doing a chin-up or hanging from a bar. Now you have to be careful about the angles they're giving you here. 30 degrees, that's not the usual angle. You're used to getting that angle between the force and the x-axis, but now it's between the force and the y-axis. That's okay, because hopefully your trig is good enough. Okay, we have the weight, that they mean the force of gravity. So that's mg. So that's the 6 kilograms times 9.8. And so the force of gravity there is 58.8 newtons. And then it also says that there's an external force. Someone else is pulling down on this thing with a force of 410 newtons. So it's quite big. Okay, and the question is, what is that tension force in each of those ropes? Okay, so let's do our table. There we go this way. Now we could do a table, or we could just do up equals down. If you draw the components of those tension forces, we have the y components and the x components. Now, because that angle is 30, look at the triangle that you're working with. This is t, that's the hypotenuse. This is 30. This is ty, and this is tx. Now notice how tx is opposite the angle, and so tx would be t sine 30. You're used to having it t cos 30, but because it's a different angle here, the ty is the t cos 30. Okay, so this one up is t cos 30, and this one is t cos 30. This one is t sine 30, and this one is t sine 30. And then we've got the 410 and the 58.8. Okay, now obviously the left and the right balance, because it's this t sine 30 and t sine 30. The 2 up must equal those 2 down. So we have t cos 30. So this is just up equals down, plus another t cos 30, must equal 410 plus 58.8, which is 468.8. This is 2t cos 30. And so t would be 468.8 divided by 2 cos 30. And that would be the tension in that, both those ropes. And that works out to 271 newtons. Okay, so that's the answer. Okay, let's keep going here. Number 5. Okay, so this is similar to one of the ones you had with the foot in traction. Okay, so we have a block here. Well, it's actually the knot. The knot of the ropes is what's in equilibrium. And it's the force of gravity of this mass pulling down on the knot. Now, and then you have to think about what are the ropes doing? Remember, ropes only pull. So the knot is the point of interest, not the mass. So this is essentially our point of interest. So we've got the force of gravity due to this hanging mass down, Fg. We've got this rope pulling. Remember, ropes can only pull. And so I guess we'll call this maybe T1 for tension. And this would only pull as well, T2. Okay, so those are the three forces that are in equilibrium. Now we've got to translate this angle down to our mass. Where does that angle go? So let's do our X and Y. So I'm going to put my mass over here. I'm going to do my X, my Y. I've got T1, I've got FG, I've got T2. Okay, so there's our triangle of, there's our three forces. Now this angle here is the same as this one because of that fancy thing in geometry where if you have parallel lines intersecting and then there's called opposite interior angles, this one and this one are equal. This one's equal too. And this one's equal too. There's lots of equal angles there. Those are all equal. Okay, so here's our theta. Okay, now let's see what we have. We've got some information here. We know that T1 is 38. So that's good. And we know the T2 is 59. Okay, and now it doesn't tell us the mass M. 38, 59. Okay, but do we need that? We don't need that. We can actually work out, remember we have two equations here. So let's do our table. We're going to do our XY table this time. It's a little bit easier probably to see what's going on. And we've got T1, T2, and FG. T1, T2, FG, those are the three forces. They have to add to 0. Okay, so T1, it's got 38 in the X, nothing in the Y. T2, in the X, it's left, so it'd be negative 59 cos theta. In the Y, it points up, it would be 59 sine theta. FG has nothing in the X, and it would be negative mg, whatever m is, we don't know. We could work out m if we had to. But it turns out, notice how we've got two unknown quantities here. We don't know theta, so that's unknown. And we don't know m. That's also unknown. But we have two equations. And whenever you have two equations, you can figure out two unknown quantities. But right now, they're only asking for theta. So let's do the x direction equation. We go down that column. We have 38 minus 59 cos theta plus 0 equals 0. And so 38 must equal 59 cos theta, or cos theta is 38 over 59. Now this always has to be a number less than 1. If you get a number for cos theta bigger than 1, you've goofed. you'll get an error on your calculator. And so it turns out that inverse cos, so arc cos of 38 over 59 is equal to 50 degrees. And that's equal to theta. Okay. Now, if we wanted the mass, we could go back and we could put that theta in here, do the y direction and calculate the mass, but that's not the question this time. Okay, let's carry on. Number 7. 10 kilogram picture is held in place by 2 wires. So sometimes the tricky thing is getting the picture. So you have to read it carefully. When it says 10 kilograms, then you immediately know the force of gravity is 10 times 9.8. Okay, so we've got 98 newtons straight down. 2 wires. First one hanging at 50 degrees to the left of the vertical. Okay, here's the vertical. Left of vertical, that's 50 degrees. Okay, and it just calls it T1. We'll call it T1. And the second one is 45 to the right of the vertical. So this would be 45. That would be T2. They're not equal to each other. What is the tension in the first wire? Okay. So what do we have here? That's a little tricky question. Oops. Oh, there goes my dog. Okay, so let's do the XY, but you can handle it. You've done these XY so many times now. It's now just algebra after this. When you have the angles, it does make life a little bit easier. Okay, so we've got T1, T2, and FG. And these have to add to 0. 0 and 0. Okay, so T1 and the X. Now, once again, these angles are with respect to vertical. Now, you could always work out the angles with respect to horizontal. This must be 45 because 45 plus 45 is 90. And this must be 40. So if you're just much more comfortable using, this would be the cos. This would be T2 cos 45 for X. And this one would be T1 cos 40, pointing left. But you'll see that cos 40 is exactly the same as sine 50. So it doesn't matter whether you use cos 40 or sine 50, you're going to get the same number for T1x. But I'll use those cos ones. So it's negative because it points left, T1 cos 40. And then y is up, T1 sine 40. T2x is T2 cos 45 and T2 sine 45. And then FG is 0 and 98, negative because it's down. Okay, so we now have 2 equations. They're actually simultaneous equations. They both have 2 unknowns. So it's not quite as easy to solve them, but it's doable. Okay, so we have negative T1 cos 40 plus T2 cos 45. Remember, cos 40 and cos 45, they're just numbers. That has to equal 0. That's equation number 1. In the y direction, we have T1 sine 40 plus T2 sine 45. Minus 98 equals 0. That's equation number 2. Okay, so the way you solve this is you solve number 1 for T1 and then you sub it into number 2. So I would probably never give you one this tricky, but that's okay. We're going to do it anyway. So, I mean, on a test, I wouldn't. So solve number 1 for T1. So I get that. Okay, I'm going to take it over to the other side. So I'm going to go like this. I'll just switch signs. T1 cos, or I have to keep flipping up. Cos 40 must equal, because one's positive, one's negative, T2 cos 45. So T1 is equal to T2 times cos 45 over cos 40. And I'm going to work that number out. Cos 45 and cos 40. Okay, so this is 0.92, 0.92 T2. Okay, now I'm going to sub that in, sub T1 into equation 2. Okay, so go back to equation 2 and it says T1 sine 40 plus T2 sine 45. So instead of T1, I'm going to write 0.92 T2. Don't forget the sine 40. Plus that's, so this is my T1. And then T2 sine 45 must equal 98 newtons, because I took the negative 98 to the other side. Okay, now I can factor out T2, and I get 0.92 sine 40 plus sine 45 must equal 98. Work out that number in brackets there. And the number in brackets is 1.30 is equal to 98. And so T2 is equal to 98 divided by 1.30. And so that's 75.4 newtons. But that's not the one we want. The first wire is to the left. So I think that's we want T1, not T2, but that's okay, that we had to do that anyways. So I go back to what T1 is. There's T1 right there, 0.92 T2. So T1 is 0.92 T2. So it must be 0.92 times 75.4. 69 newtons. It's T1. Okay, now that's a little bit too tricky, I think, at this level, but that's a good question. Okay, I think I'll quit there and then we'll finish the other ones in another video.